to another episode of the Jarring Science Club. I'm your host, Brenda. Today we're going to be exploring chemical versus physical changes using an egg. For this experiment, you're going to need an egg, a fork, a jar, a small frying pan, and a hot plate or stove. Alright, let's get to it. Alright, here we have our jar, and we have our lid, and we have our egg, and we are going to first physically change this egg, and then we will cook it and chemically change it. If you were not old enough to use a stove, you may want to get the help of an adult for this one. So first we're going to crack our egg into our jar. And there it is, all the pieces. I've already broken it up a little bit, so the physical changes are already starting. Then I'm going to put on my lid here and give it a shake. Now we have scrambled the egg and made a physical change. But how could we make it chemically change? A chemical change must change the chemical structure of the material. And the easiest way to do that with an egg is by cooking. So that's what we're gonna do. All right, I got my little hot plate here. And we're gonna pour our egg into here and see if we can get it to chemically change by heating it. Now we're just going to wait a minute and see what happens. The chemical change is already starting. Now the structure of the egg molecules are completely changing. Air is getting added, and the cooking of the egg is completely changing the way that the molecules are bonded. You can't uncook an egg, so that's what makes this a chemical change. And at the end, you have some tasty eggs to eat. Here's the science. In this lesson, we explored the difference between a chemical change and a physical change using an egg. Everything that exists in the world has matter. Air has matter, bodies have matter, objects have matter. Eggs have matter. Matter is simply how molecules are held together, making up something. Matter can change in two different ways. It can have a physical change. Physical change is when matter changes shape or form, but no chemical processes change. The chemical identity of that material, that piece of matter, stays the same no matter what form it is taken. That means that the mass of the matter will stay the same. Physical changes include things like boiling, freezing, melting, and breaking something apart to form smaller pieces. All of the same pieces are there, they just happen to exist in a different form. A chemical change is where things get interesting. Chemical changes introduce new forms to matter and change it often irreparably. In a chemical change, something about the item changes almost permanently. The only way to undo a chemical change is with another chemical reaction. Examples of chemical changes are things like rust, rotting, cooking, and burning. In our egg example, when we broke the egg apart and mixed it up with a fork inside of our jar, that was a physical change. Nothing about the egg changed except its shape and how it was mixed together. But when we cooked the egg, we introduced heat. The heat changed the way that the egg molecules bonded, making something new. You can't uncook an egg, which means that that's a chemical change. However, it is possible, although somewhat difficult, to separate the parts of an egg that have just been stirred. Here are some things that you can do that are physical changes. Crumpling up a piece of paper, melting an ice cube, molding something into a new shape, like Play-Doh, or maybe even melting metal, breaking an object into smaller pieces, evaporating a liquid, or shredding paper into small bits. Here are some examples of chemical changes. Milk, when it changes from milk to butter or yogurt. Burning wood, when you mix an acid and a base, like in a classic vinegar and baking soda volcano. Digesting food, cooking an egg like we did. Making a cake or cooking other kinds of food. And then rust on metal. So how can you tell if something is a physical or chemical change with absolute certainty? The best way to do it is to think about what constitutes a chemical change. Chemical reactions can release or absorb heat. They can release gas, a smell, a color, or a sound. Sometimes it can be a little bit difficult to tell if it is a physical or chemical change, but in general, if a big reaction occurs, it's more than likely a chemical change. Whereas things are just moving around, it's probably a physical change. That's it for today. See you next time.